On this next problem, I'm going to pretty much just set it up and show you kind of where numbers go, but then I do want you to work through it algebraically by yourself. I'm looking at exercise 2, number 1, and this is just putting into words what you're actually going to be doing in the lab on Monday. And this is a good one also because it kind of shows you some of those values that we're going to be looking for, and so we're just going to plug straight in. This is wanting us to calculate the equilibrium temperature. So what's the equilibrium temperature? That's that final temperature. So that's the variable that I'm going to be solving for as I move forward here. It tells me that I have 30 grams of copper. So over here, go ahead and fill in 30 grams for your mass of copper. It's at 90 degrees Celsius. So again, there's that initial temperature. I can already see I'm not going to like the sig figs on this, but we'll deal with that later. It's added to 80 grams of water. So let's come over here and plug in our mass for 80 grams of water. And that initial temperature is 10 degrees Celsius. Use the following equation, and we see right here again that we're looking at heat lost equals heat gained by the water. This is just solving for a new variable. I'm looking at some distributive property, and again, I'm going to plug it into the equation, which you should be able to do, but the math on this, the algebra on this definitely kind of has to make you think a little bit. So let's go ahead and say that looking at the mass of the metal would be 30 grams times the specific heat is 0.385 times, here's where that final minus initial, we don't know what the final temperature is, so I'm just going to put a T in there for final temperature minus, I know that the initial temperature here is 90 equals, you see here I'm running out of room, so I apologize, I'm going to drop right down here. Now let's look at the water. This is how much heat's gained. That would be 80, because that's the mass of the water, times 4.184 times, again, it told me that the initial temperature of the water was 10 degrees, but I don't know the final temperature. That's the temperature that I'm looking for here. So again, I'm going to put T minus initial temperature is 10. And so from here, you're going to need to do some distributing and go through and solve for T on that one. Looking down here at number 2, why does the water temperature change much less than the temperature of copper? And again, I want you to think through this, but let me give you a little bit of a hint. Let's just look at copper. Copper has a specific heat of 0.385 joules per gram degrees Celsius, and water, H2O, has a specific heat of 4.184 joules per gram degrees Celsius. And we talked about this in class on Friday. Think about what those numbers mean. Does it really take a lot of heat to heat up copper? No, it only takes 0.385 joules. But look down here at the water. It takes a lot more heat to heat up the water. And so that is really what's going to help us answer this question. Try to put that in your own terms, but focus in on those specific heats and the why behind that. This last one, you could definitely go back to that simulation and use the website from earlier. For each metal, experiment with the change in mass. Do not change the mass of water. So ultimately what we're saying is if you increase the mass of the metal, so again, come back over here, look at your original data. What happened when we increased the mass of the metal to the final temperature? And that's what this is asking you. What happens to the equilibrium temperature if you decrease it? And again, I want you thinking about why that happens. Think about the formula that's used and things like that. Those are really all the hints that I'm going to give you on the pre-lab. I'll take other questions you might have in class on Monday and Tuesday.